Welcome to Keentel Engineering. Starting April 1st, 2027, NERC's BAL-007-1 standard shifts grid reliability planning from capacity to energy, asking not just whether enough megawatts are available, but whether enough megawatt-hours are available over time. If you're a balancing authority, developer, or asset owner, this changes how near-term reliability gets assessed. Here's what the standard requires and how to get ahead of it before 2027. The old model asked one question: is enough capacity available right now? That's no longer sufficient as inverter-based resources, solar, wind, and storage, reshape the resource mix. The new standard asks a different question: is enough energy available over time? BAL-007-1 ensures sufficient energy is available, not just instantaneous capacity. Keentel helps utilities, developers, and asset owners navigate that transition while staying fully compliant. The standard breaks into three requirement groups. Requirements 1 through 3 cover ERA development, defining modeling assumptions, building scenarios, and creating operating plans with either deterministic or probabilistic methods allowed. Requirement 4 covers ERA execution, performing assessments routinely across all relevant time horizons with current data. And Requirement 5 covers risk identification and mitigation, triggering operating plans on a forecasted energy emergency aligned with the Energy Emergency Alert Framework. What actually makes an ERA different from a traditional capacity study? Traditional studies are snapshot-based. ERAs run time series analysis. Traditional studies are megawatt-focused. IRAs are megawatt-hour focused. Traditional studies ignore fuel depletion, ER, as model fuel constraints, and traditional studies look out to next day. ERAs extend up to a 6-week horizon. 3 categories of modeling now matter: fuel modeling, covering natural gas constraints, coal and oil inventory depletion, hydro limitations, and renewable variability; resource types, covering dispatchable generation, energy storage like battery systems and pumped hydro, and variable renewables; and transmission constraints. Known deliverability limits have to be included, though full power flow isn't required. BAL-007 also requires stress testing through 4 scenario types: demand stress, high-load scenarios like a 90-10 peak; supply loss, the loss of a major energy resource; fuel-based risk, the loss of a common fuel supply like the gas system; and historical or extreme events, weather-driven scenarios like snow, smoke, or wind drought. Every scenario must be credible and documented. This is where BAL-007 really changes things. It emphasizes proactive mitigation over reactive response. Example actions include rescheduling outages, securing additional fuel, optimizing storage dispatch, increasing imports with caution, and coordinating with reliability coordinators. Other examples include recalling generation from maintenance, deferring outages, increasing ERA frequency, and preparing thermal units ahead of cold weather. BAL-007 operates days to weeks ahead of an event, not hours. That window enables preventive action, reduces reliance on emergency procedures, and improves coordination across regions. For industry stakeholders, 3 challenges stand out: data requirements, needing coordination through TOP-003 updates and multi-entity data integration; modeling complexity, time series simulations, fuel supply modeling, and renewable uncertainty; and operational coordination, interchange assumptions, and cross-balancing authority dependencies. Here's how Keentel supports BAL-007 compliance end-to-end: ERA model development, integrating PSSE, TSAT, Power Factory, and PSCAD into time series simulation frameworks; scenario design, building region-specific stress scenarios for weather, fuel, and contingencies; operating plan development, custom mitigation strategies aligned to the Energy Emergency Alert Framework; compliance documentation, audit-ready packages covering requirements 1 through 6, and advanced studies, fuel risk analysis, renewable variability assessment, and storage optimization. What is BAL-007-1? A NERC reliability standard focused on near-term energy adequacy assessments. What is an ERA? An energy reliability assessment evaluating energy sufficiency over time. What's the time horizon of a near-term ERA? 5 days to 6 weeks. Why is BAL-007 needed? Capacity-based planning doesn't capture energy risks. Who must comply? Balancing authorities. What's the difference between capacity and energy? Capacity is megawatts. Energy is megawatt-hours over time. Does ERA require probabilistic modeling? No. Deterministic or probabilistic methods are both allowed. What are key ERA inputs? Load forecast, resource availability, fuel supply, and transmission constraints. Are renewables modeled differently? Yes, variability and uncertainty must be included. What is a forecasted energy emergency? A predicted shortfall aligned with energy emergency alert criteria. How does BAL-007 relate to EOP-011? BAL-007 is proactive. EOP-011 is reactive. Does ERA replace TOP-002? No, it complements it. How often must ERAs be performed? Regularly, covering all time periods. What are the required scenarios? Demand stress, supply loss, fuel supply risk, and historical events. Are transmission constraints required? Yes, known constraints must be modeled. Is power flow required? No, but constraints must still be represented. What fuels must be modeled? Gas, coal, oil, hydro, and renewables. How is demand response treated? Optional, depending on the balancing authority's assumptions. Can ERAs be done jointly? Yes, multiple balancing authorities can collaborate. What triggers operating plans? A forecasted energy deficiency. What are typical mitigation actions? Rescheduling outages, fuel management, and storage optimization. Are imports considered firm? No, they must be verified. How often must processes be reviewed? At least every 24 months. What software is used for ERA, PSSE, and TSAT, PSCAD, Power Factory, and MATLAB? How can Keentel help? Through modeling, compliance support, and operational strategy development. Having enough megawatts isn't the same as having enough energy. NERC's BAL-007-1 standard shifts grid planning from capacity adequacy to energy adequacy. Verifying enough megawatt-hours exists over a 5-day to 6-week window. Balancing authorities now model fuel constraints, run stress test scenarios, and trigger operating plans before a shortfall becomes an emergency. It's proactive, not reactive. At Keentel Engineering, we build ERA models, scenario frameworks, and audit-ready compliance packages using PSS/E, PSCAD, and Power Factory. Visit keentelengineering.com.